Welcome back. This is a question that is asking us to express our answer in partial fraction. And we have a quadratic function here, x squared plus 6, which is not factorizable or not reducible. So whenever we have a question that asks us to express our answer in partial fraction, but the denominator is having a quadratic function that is not factorizable, then there is a special way of answering the question. Let's give some examples. So let's say we have x squared minus 3 all over x plus 2 into x squared minus 5. Here we have a quadratic function x squared minus 5 that we cannot factorize. Then the way we're going to solve this is we're going to have a all over, this is a linear function, so we have no problem with it. So that is going to be x plus 2 plus, for this x squared minus 5, we cannot say b all over x squared minus 5. That will be wrong. Here, whenever you have such a situation, you need to introduce another term, okay? So therefore you will say bx plus c, where c is the order constant. Then you continue solving the usual way of solving partial fractions. Let's give another example. If we have, let's say, x squared minus 4 all over x minus 3 into x squared minus 2. Here again, we have a quadratic function. So this is going to be a all over x minus 3 plus bx plus c all over x squared minus 2. Another example, x squared minus, let's say, 4 all over x squared plus 2 into x minus 5. We will say ax plus b all over x squared plus 2, then plus c all over x minus 5. Okay, so since x squared plus 2 is what we have first here, so we can say a, but it will be with b. Okay, so the two constants will come together. It will be ax plus b all over x squared plus 2 plus c all over x minus 5. All right, and finally, if I have, let's say, x squared minus 3 all over x plus 5 into x squared minus 2x plus 5. So again, we have a quadratic function here, okay, that is not factorizable, okay? This quadratic function is not factorizable similar to this quadratic function. So it's the same approach, because if you find the ax term of this quadratic function is positive 5 and the bx is minus 2, so there is no two numbers that you can multiply to give you 5, and when you add those two numbers to give you negative 2. Okay, so which means this quadratic function is also not factorizable or not reducible. So the approach will be the same. What we're going to do is we're going to have a all over x plus 5 plus bx plus c all over x squared minus 2x plus 5. And then we continue solving. So if this concept is clear, we can now move on to solve our problem. So We have the question and it reads, express x squared plus x minus 15 all over x minus 3 into x squared plus 6 in partial fraction. Solution, we have x squared plus x minus 15 all over x minus 3 into x squared plus 6. So we're going to have x squared plus x minus 15 all over x minus 3 into x squared plus 6. This is equal to a all over x minus 3 plus bx plus c all over x squared plus 6. Then what do we have next? We'll have x squared plus x minus 15 all over x minus 3 into x squared plus 6. This is equal to a all over x minus 3 plus bx plus c all over x squared plus 6. Then what we do with this is we multiply everything with the denominator that we have here, which is x minus 3 into x squared plus 6. So if x minus 3 into x squared plus 6 goes into this, that will be 1 times x squared plus x minus 15 is just x squared plus x minus 15. This is equal to, if x minus 3 goes into this expression, the x minus 3 will cancel out. So we'll be left with x squared plus 6. That will be multiplied by a. So we'll have a into x squared plus 6 plus, if x squared plus 6 goes into this expression, the x squared plus 6 will cancel out. So we'll be left with x minus 3. That will be multiplied with bx plus c. So we'll have bx plus c into x minus 3. So what do we do next? We can try to see which of the brackets can we make 0. So for here, to make this bracket 0, x have to be positive 3, such that 3 minus 3 becomes 0. Okay? So let x is equal to 3. All right? If that is the case, we'll have 3 squared plus 3 minus 15 is equal to a into 3 squared plus 6 plus b into 3 plus c into 3 minus 3. So 3 squared is 9 plus 3 minus 15 is equal to a into 3 squared is 9 plus 6. So because 3 minus 3 is 0, so 0 times any other thing will be 0, so we can forget that. Therefore, 9 plus 3 is 12 minus 15 is minus 3 is equal to a into 9 plus 6 is 15. So what do we have? We have minus 3 is equal to 15a. To find a, we need to divide both sides by 15. This will cancel this. So a is equal to minus 3 over 15, which is the same as minus 1 all over 5, right? So we are able to find a. But what can we do to find b and c, since they are important constants for us? Well, we still need to use this expression, expand it further, and then we can do comparison. Okay? Again, using x squared plus x minus 15 is equal to a into x squared plus 6 plus bx plus c into x minus 3. What we need to do is we have to expand the brackets. Okay, so that will be x squared plus x minus 15 is equal to a into x squared plus 6 plus, for this side we need to take the bx, multiply with x minus 3, then we take the c and multiply with x minus 3. So if we do that, it means we have multiplied everything. So that will be bx into x minus 3 plus c into x minus 3. Okay, so that is x squared plus x minus 15 is equal to a times x squared is ax squared plus a times 6 is 6a plus bx times x is bx squared minus bx times 3 is 3bx plus c times x is cx minus c times 3 is 3c. So that is x squared plus x minus 15 is equal to, what we need to do here at this stage is to bring the terms that have x squared together, then bring the terms that have x together, then take the remaining on the other side. So because quadratic equation is defined as ax squared plus bx plus c, right? So let's arrange it in that order. We will have ax squared plus bx squared, then minus 3bx plus cx, then plus 6a minus 3c. So then what do we have to do? We are going to do comparison. Okay, we're going to compare what we have on the left side of the equation with what we have on the right hand side of the equation. All right, so it means the terms that have x squared will match with the terms that have x squared. The terms that have x will match with the terms that have x, and the constant number will match with the terms that do not have either x squared or x. So let's show that. Okay, so x squared will be compared with this. X will be compared with minus 3bx plus cx, and minus 15 will be compared with this. Okay, so with that we will say x squared is equal to ax squared plus bx squared, right? So x squared is the same as 1x squared, right? Now what is common here is x squared. We can factorize that out. So we'll have x squared into 1 is equal to x squared into a plus b. Okay, then when we do that, it means this x squared can cancel this x squared, then 1 is equal to a plus b. So that can also be said as a plus b is equal to 1, and let's call this equation 1. Okay, so this x will be equal to minus 3bx plus cx. That is, x is equal to minus 3bx plus cx. What we need to do, we can factorize x out. So that will be x into 1 is equal to x into minus 3b plus c, right? Yeah. So x will cancel x. Then we'll have 1 is equal to minus 3b plus c. So it means we can say minus 3b plus c is equal to 1. We can also be written as c minus 3b is equal to 1. Let's call this equation 2. Okay, so moving on, we will have this constant value minus 15 to be equal to plus 6a minus 3c. So 15 is equal to 6a minus 3c. So what can we do with this? We can factorize 3 out. Is possible, right? So that will be 3 into 5 is equal to 3 into 2a minus c. Is that correct? Yeah, the factorization is correct because 3 times 2 is 6, 3 times c is 3c, and 3 times 5 is 15. So with this, 3 can cancel 3. Then we have 5 is equal to 2a minus c. That is, we can say 2a minus c is equal to 5. All right. So this can be equation 3. So what we need to do, we'll substitute to be able to find a, b, and c. Okay. We have obtained a plus b is equal to 1 as equation 1. And we obtain c minus 3b is equal to 1 as equation 2. And 2a minus c is equal to 5 as equation 3. And we have already calculated the value of a as minus 1 over 5. So with this information, we can be able to calculate b and c. Or even by substituting one another, we will still be able to have a as minus 1 over 5 again. But let us not make the work difficult. So from equation 1, a plus b is equal to 1, and a is minus 1 over 5, plus b is equal to 1. So b will be equal to 1 plus 1 over 5. So b will be equal to 1 over 1 plus 1 over 5. If we find the LCM is 5. 1 into 5 is 5 times 1 is 5. Plus 5 into 5 is 1. 1 times 1 is 1. So b will be equal to 6 over 5. Okay. And again, from equation 2, we've said that c minus 3b is equal to 1. So that is c minus 3 into b is 6 over 5 is equal to 1. So that will be c minus 3 times 6 is 18 all over 5 is equal to 1. So to find c will be equal to 1 plus 18 over 5. That is c is equal to 1 over 1 plus 18 over 5. Then we find the LCM, and the LCM will be 5. So 1 into 5 is 5 times. 5 times 1 is 5. Plus 5 into 5 is 1 times 1 times 18 is 18. So C is equal to 5 plus 18, which is 23 all over 5. Okay, so C is 23 over 5. Now we know A, we know B, we know C. So we will now go back to this equation and substitute the values of A, B, and C, okay, for this expression. So that is, we had x squared plus x minus 15 all over x minus 3 into x squared plus 6 is equal to A all over x minus 3 plus bx plus c all over x squared plus 6. So that will be A is minus 1 over 5 all over x minus 3 plus B is 6 over 5 x plus C is 23 over 5 all over x squared plus 6. So that will be minus 1 over 5 all over x minus 3 plus, we can be able to simplify this and give the answer. Okay, then that will be divided by x squared plus 6. So let's try to do that somewhere separate. If we have 6 all over 5 x plus 23 over 5, that is the same as 6 times x is 6x over 5 plus 23 over 5. So what do? We find the LCM. The LCM will be 5. 5 into 5 is 1 times 6x is 6x plus 5 into 5 is 1 times 23 is 23. So it means we're going to have 6x plus 23 all over 5 that we can substitute. Okay, so we will substitute 6x plus 23 over 5 instead of having this expression here. So we're going to have 6x plus 23 all over 5 over x squared plus 6. Okay, let me clear this out. So if we have minus 1 over 5 divided by x minus 3, that is the same as minus 1 over 5 times 1 over x minus 3. Okay, so minus 1 times 1 is minus 1 all over 5 times x minus 3 is the same as expressing it as 5 into x minus 3. So we'll try to write that as minus 1 all over 5 into x minus 3. Okay, plus, if we have 6x plus 23 all over 5 divided by x squared plus 6, that is the same as 6x plus 23 all over 5 times 1 all over x squared plus 6. So we're going to have 6x plus 23 all over 5 into x squared plus 6 is the same as leaving our answer as 5 into x squared plus 6. So that is what we can write. Okay, we'll have 6x plus 23 all over 5 into x squared plus 6. So because we have a negative here, if we want, we can write this first and the negative will be in between. So that is 6x plus 23 all over 5 into x squared plus 6 minus 1 all over 5 into x minus 3. That is all for today. Please subscribe to the channel, like and share our videos.